Hello and welcome to another RLabs tutorial. In this video, we will learn a little bit about the apply family of functions. These apply functions are essentially implicit loops which iterate over the elements of an object, like a data frame or a list, etc., and execute some specified set of commands. In the next few videos, we will briefly look at 4 of the apply functions, but note that there are others as well that are just less commonly used or needed. This video will focus on the first member of the apply family of functions, and that is the apply function. The apply function takes a minimum of 3 arguments. The first argument is the object that you will be working with, and in the case of apply, we can input either a matrix or a higher dimensional array. And just to clarify, a matrix is simply a 2-dimensional array, the 2 dimensions being rows and columns. But arrays can have more than 2 dimensions as well. So for example, in addition to rows and columns, here we have added one more dimension. We are essentially stacking multiple matrices. Okay, so the next argument is the margin, and the margin specifies which dimension or dimensions to iterate over. So specifying 1 means that we want to operate over the first dimension, or rows. Specifying 2 indicates that we want to apply the function to the second dimension, the columns, and so on and so forth. If we specify concatenate 1, 2, we are saying that we want to iterate over the columns and the rows. Finally, the third argument is the function that you want to apply to the chosen margin. You can also add other arguments as well at the end, as we will see later on in some examples, and these additional arguments are the arguments specific to the function that is being applied, but we'll deal with that a little bit later. So here in our studio, we will stick to a simple matrix example for the purposes of this tutorial, but just remember that other arrays work in the same way. So here's an example of a matrix, and I'll add some row names and some column names to it, and here it is. And we can just verify that it is indeed a matrix by calling up the class, and we can see that it definitely is. Now, I just made up this data, but we can imagine that we are examining the growth of duckweed over several days for several replicates, and we are counting the number of leaves present each day. So all of the numbers in the matrix here are numbers of leaves. Now, with these data, we might be interested in finding the maximum number of leaves that were counted on each given day out of all of the replicates. So that would be finding the maximum value in each row. Now we could certainly go through and write 10 different commands to find the maximum value in each row. So here we are saying that we want to find the max of the first row in the duckweed.max matrix. Now just a reminder that the numbers in square brackets following the name of a matrix refer to the position of a row and or column within the matrix. So separated by a comma, the row address comes first and the column address comes second. So we can do this for all 10 rows. But that is quite a bit of writing. Now alternatively, we could write a for loop as well if we wanted to, but that also involves a fair amount of coding, as you can see here. Now luckily, the apply function allows us to do the same thing just by writing a very small bit of code. So we can say apply, and we are working with the duckweed.mat matrix as our object. So that is our first argument. We said that we are interested in finding the max value for each day, so in this case we are applying the function to each row, and therefore our margin argument is 1. And then the function that we want to apply is the max function. And we get this nice vector that tells us the maximum number of leaves that were counted on any given day. So basically, the max function took each row as an input one by one, and then all of the individual outputs were compiled into a single output. And we could do the same thing for the column if we wanted to by simply specifying 2 as the margin instead of 1. And there we go. Now oftentimes we might be working with data frames in R instead of with matrices. Recall that a data frame is very much like a matrix, but it is able to contain elements that are of different modes or classes, whereas matrices cannot. So you might be wondering if you can still use the apply function on data frames. And the short answer is yes, you can. But depending on the structure of the data frame and what function you want to apply, you might have to specify which part of the data frame you want to use the apply function on. So for example, here's the same data that was in the matrix, But now I have specified that I want to store these data in a data frame. And we can check to make sure that it is indeed a data frame. Yep. And now let's just take a peek at the data frame. So again, each column represents a different replicate and each row represents a different day. And we can use the apply function on this data frame in the same way. So this time, let's find the mean number of leaves on each day. So the means of the rows. Now we could just as easily use the row means function, but again, we're just showing you some simple examples of how the apply function works so that you can later use the function for more complex tasks. So we can see that the apply function obviously still works here. But data frames are not always so simple. This data frame is matrix-like in the sense that all of the elements in the data frame are of the numeric class, but they don't have to be. So for example, I will add in a day column to our duckweed data frame. And since we are dealing with days 1 through 10, I have specified that the values in the day column are going to be numbered 1 through 10. But you can see here that I have specified that I want these 10 elements in the column to be considered factors. In other words, they are not numbers that I would want to add up or take the average of or manipulate. I could just have easily have used day A, day B, day C, etc. And then this command here just allows me to rearrange the columns of the data frame so that the new day column is the first column instead of being tagged on to the end of the data frame as the 7th column. So now let's just view our data frame, and we can make sure that the elements in the day column are being treated as factors. Good. But now if we wanted to find the mean number of leaves counted on every day in every row, we can see that the command does not work because we added a factor to every row, and you cannot take the mean of a mixture of numeric values and factors. But what we can do is exclude the day column from the apply function, and we do this by referring to the indices of columns within square brackets. So for example, we want to apply the function to the duckweed.dataframe still, but only to columns 2 through 7. i.e. all columns except the first column, the day column. And you can see that it definitely worked. The day factors were evidently excluded from the calculation of the mean. Now instead of listing all the columns that we want to include in the apply function, we could have just as easily specified the columns that we want to exclude, namely the first column, the day column. And we do this by including a little negative sign in front of the column index 1. And you can see that it worked in the same way. Now, if we wanted to exclude several columns, we don't in this situation, but just in case you ever wanted to, you can use the negative sign in front of a vector containing indices of all the columns that you want to exclude. So that certainly works. We have excluded the values from the first, second, fourth, and sixth columns from the calculation of the row means. Now, sometimes when you're collecting data, there might be some missing values. So here's our data. There aren't any missing values right now, but let's pretend that on the 6th day, we just could not for some reason collect the data from the 6th replicate. So that would be in the 6th row, 7th column. And we're going to override the current value of 130 and instead make it NA. So now there's our NA value right there. Now if we try our apply function, we can see that we get an NA returned for the output corresponding to the 6th row. If we decide that it's okay to ignore the single NA entry that we have in our data frame in order to get a numeric output for this 6th row, then we can go ahead and tell R to calculate the mean with the values that are present and ignore the NA value. And we do so using the argument na.rm, which stands for NA remove. Now you probably know that na.remove is an argument of the mean function that is normally specified within brackets when using the function. So the commands might look something like this. We have a vector x which contains an NA, and then we want to take the mean of all of the values of the vector x excluding the NA element. So we say NA remove equals true. But as we already mentioned, when using apply, arguments specific to the function being applied are input as the last arguments of the apply function itself. They are not input in brackets following the specified function. And this holds true for any argument of any function used within apply, not just for the NA-remove argument of the mean function. So let's just try that out here. And you can see that we no longer have an NA as part of the output. Now what happens if we wanted to apply a function that does not exist? Well, you can make your own function. We have a lesson on how to create functions in R if you don't already know how. And then you can run your function and apply your function just like any other function. So just to show you an example, let's return to our duckweed.mat matrix. And for each replicate, we might be interested in knowing the proportion of the total number of leaves we counted on each day. There is no function that I know of that does this, so we can make up our own function like this. So this function takes x as an input, where x is some vector, and then for each of the elements of x, the function is going to return the value of the element divided by the maximum value of the vector. And now we can apply that function to the duckweed matrix. And since we have specified 2 as the margin, each one of the columns of the duckweed.mat matrix is going to act as an input vector x of the function. Now you can see here that we got a whole matrix as an output instead of just a vector. And that is one of the cool things about the apply function, is that it can return different objects depending on what function is being applied. Typically either a vector or a matrix or an array is returned, but if the output cannot be simplified into a vector or matrix or array, then a list can be returned as well. Thanks for listening to this R Labs tutorial video. If you found this useful, you might be interested in our free online Moodle course, or check out and subscribe to our YouTube channel.